Mathematics is an essential part of our daily lives, but have you ever wondered about its origins? The history of mathematics dates back to ancient times, where it was used for practical purposes such as counting, measuring, and trading. In this segment, we will explore the beginnings of mathematics and how it evolved over time. The earliest evidence of mathematical concepts can be traced back to the Babylonians, who lived in Mesopotamia around 2000 BC. They developed a number system based on the number 60, which is still used today for measuring time and angles. The Babylonians also created the first known mathematical texts, which contained problems related to geometry and algebra. Around the same time, the Egyptians were also developing their own mathematical system. They used a base 10 system and had a good understanding of fractions and geometry. The Egyptians used mathematics for practical purposes such as measuring land and building pyramids. In ancient Greece, mathematics became more theoretical and abstract. The Greeks were interested in the study of geometry and developed many important concepts such as the Pythagorean theorem and Euclidean geometry. They also made significant contributions to the study of number theory and created the first known proof of the infinitude of prime numbers. During the Middle Ages, mathematics continued to develop in the Islamic world. Mathematicians such as Al-Khwarizmi and Omar Khayyam made significant contributions to algebra and geometry. They also developed the concept of zero, which revolutionized mathematics and paved the way for modern mathematics. In the Renaissance period, mathematics became more closely linked to science. Mathematicians such as Galileo and Newton used mathematics to explain the laws of physics and the motion of objects. They also developed calculus, which is still used today in many fields such as engineering and physics. In conclusion, the history of mathematics is a long and fascinating one. From its practical beginnings in ancient times to its more abstract and theoretical developments in modern times, mathematics has played a crucial role in shaping our world. In the next segment, we will explore the contributions of some of the greatest mathematicians in history. Throughout history, there have been many great mathematicians who have made significant contributions to the field. In this segment, we will explore the lives and achievements of some of the greatest mathematicians in history. One of the most famous mathematicians of all time is Archimedes. He lived in ancient Greece and made important contributions to geometry, calculus, and mechanics. Archimedes is best known for his principle of buoyancy, which explains why objects float or sink in water. He also developed the concept of pi and calculated its value to an accuracy of 3.14. Another great mathematician was Isaac Newton, who lived in England during the 17th century. Newton is best known for his laws of motion and his theory of gravity, which revolutionized the field of physics. He also developed calculus independently of Leibniz and made significant contributions to the study of optics. Leonhard Euler was a Swiss mathematician who lived in the 18th century. He made important contributions to almost every area of mathematics, including calculus, number theory, and geometry. Euler is best known for his formula for complex numbers and his work on graph theory, which is now used in computer science and network analysis. Carl Friedrich Gauss was a German mathematician who lived in the 19th century. He made significant contributions to number theory, algebra, and geometry. Gauss is best known for his work on prime numbers and his invention of the method of least squares, which is used in statistics and data analysis. Finally, we have Alan Turing, who lived in England during the 20th century. Turing is best known for his work on code breaking during World War II, which helped to end the war. He also made significant contributions to the development of computer science and artificial intelligence. In conclusion, these mathematicians and many others have made significant contributions to the field of mathematics. Their work has shaped our understanding of the world and paved the way for modern mathematics. In the next segment, we will explore some of the most important mathematical concepts and theories. Mathematics is a vast field that encompasses many different concepts and theories. In this segment, we will explore some of the most important mathematical concepts and theories that have shaped our understanding of the world. One of the most important concepts in mathematics is calculus. Calculus is a branch of mathematics that deals with rates of change and slopes of curves. It has many practical applications in fields such as physics, engineering, and economics. Calculus was independently developed by Isaac Newton and Gottfried Leibniz in the 17th century. Another important concept in mathematics is geometry. Geometry is the study of shapes, sizes, and positions of objects in space. It has many practical applications in fields such as architecture, engineering, and art. The ancient Greeks made significant contributions to the study of geometry, and it remains an important field of study today. Number theory is another important branch of mathematics. It deals with the properties of numbers and their relationships to each other. Number theory has many practical applications in fields such as cryptography and computer science. It has also been the subject of much research throughout history, with many famous mathematicians making significant contributions to the field. Probability theory is a branch of mathematics that deals with the study of random events. It has many practical applications in fields such as statistics, finance, and insurance. Probability theory was first developed in the 17th century by mathematicians such as Blaise Pascal and Pierre de Fermat. Finally, we have set theory, which is the study of sets and their properties. Set theory has many practical applications in fields such as computer science and logic. It was first developed in the late 19th century by mathematicians such as Georg Cantor. In conclusion, these concepts and theories are just a few examples of the many important ideas that make up the field of mathematics. They have practical applications in many different fields and have helped to shape our understanding of the world. In the next segment, we will explore some of the most important open problems in mathematics. Mathematics is a field that is constantly evolving, with new problems and challenges arising all the time. In this segment, we will explore some of the most important open problems in mathematics. One of the most famous open problems in mathematics is the Riemann hypothesis. This hypothesis, first proposed by Bernhard Riemann in 1859, concerns the distribution of prime numbers. It states that all non-trivial zeros of the Riemann zeta function lie on a certain line in the complex plane. The Riemann hypothesis is one of the most important unsolved problems in mathematics and has many implications for number theory and cryptography. Another important open problem in mathematics is the P versus NP problem. This problem concerns the relationship between two classes of problems in computer science, P, which represents problems that can be solved in polynomial time, and NP, which represents problems that can be verified in polynomial time. The P versus NP problem asks whether these two classes are equal or not. It has important implications for computer science and cryptography. The Birch and Swinnerton-Dyer conjecture is another important open problem in mathematics. This conjecture concerns the relationship between elliptic curves and their associated L functions. It has important implications for number theory and has been the subject of much research since it was first proposed in the 1960s. Finally, we have the Hodge conjecture, which concerns the topology of algebraic varieties. It states that certain topological invariants of algebraic varieties can be expressed in terms of algebraic cycles. The Hodge conjecture has important implications for algebraic geometry and has been the subject of much research since it was first proposed in the 1950s. In conclusion, these open problems are just a few examples of the many challenges that mathematicians face today. They have important implications for many different fields and will continue to be the subject of much research in the years to come.